Hey everyone, this is James with Louisa, and we will be examining cooking of crystalline candies, specifically fudge. So, this experiment focused on understanding factors that influence the texture and firmness of crystalline candies, specifically fudge. And these three objectives here represent the main learning objectives for this experiment. So we were trying to explain the relationship between the boiling temperature of a sugar solution and the firmness of the resulting candy. We were identifying and discussing the factors that influence the texture and quality of crystalline candies. We were attempting to understand what a supersaturated solution is and its role in candy making. So, in this experiment, we explored how different ingredients and cooking techniques influence the texture and firmness of crystalline candies, specifically fudge.
So for our materials and methods, for our experiment, there were actually four versions of the fudge using different ingredients to see how each of the ingredients affected the texture and the crystalline structure, and also at a higher temperature and at a lower temperature. So our main recipe was, simple fudge recipe: 2 cups of sugar, half a cup of cocoa, 1 cup of cream, 4 teaspoons of butter, and 1 teaspoon of vanilla extract. I'm sorry, 4 tablespoons of butter. And then the other variations was a recipe that substituted the cream with water. And the other one was a recipe with cream of tartar. And the last recipe was cream of tartar and corn syrup. And between these four, they all had very different results, especially when it came to texture and the firmness of the fudge. So each version gave us a different texture and a different level of smoothness too. And we will discuss next.
So, if we look at the results here, on the left, we have our bar graphs representing the data, and on the right, we have our table compiling all of the data from the penetrometer depths. So we had on the top, there was a high temperature condition, which was when the temperature was reached 114 degrees, which is about 237 degrees Fahrenheit. And then on the bottom, we had a low temperature condition in which the temperature was up to 112, which is 234 degrees Fahrenheit. And then we can see on the table on the right, though, the data that are represented from the high temperature and the low temperature conditions. So the penetrometer depth, if we look at the cream of tartar, and the cream of tartar and corn syrup, they were they were different, but we notice a consistent trend in that the cream was quite high. It was the second highest. The cream of tartar was the highest, and then the cream of tartar and corn syrup was the third highest. The water was very inconsistent. In the high temperature, the water was the lowest penetrometer depth, but then in the low temperature, it was the highest penetrometer depth. So the reason for why we think this may be the case, first of all, there were no pictures for the low temperature, so we were unable to see what they looked like, whereas there were pictures for the high temperature. But we figured that um, because of the low temperature, there was not enough time for the water to evaporate. So it didn't actually create a super smooth texture. It may have actually been undercooked and a little bit wet, which is why the penetrometer was able to go so deep into it, which was different from the high temperature in which the penetrometer did not go that deep, which we assume was due to higher levels of crystallization. So another set of data were subjective acceptability characteristics. These included things like color, flavor, firmness, texture, and also appearance. And these were rated with actual words, actual descriptions. So we had to, well, they were collected for us as subjective assessments, but we had to convert them to objective measurements. So we tried to create a scale from 1 to 4 that would allow us to scale the intensity or the texture or the amount of firmness that there was, whether it was really soft to really firm. We assigned a 1 through 4 scale, which we can see each of these colors represents a different factor: color, flavor, firmness, and texture. So on the top, we have the high temperature. On the bottom, we have low temperature. And what we noticed was there was a similar trend between each of the different interfering agents that were present. In cream, we can see that there is at least a similar trend between the different characteristics. Cream of tartar, again, similar trend. Cream of tartar and corn syrup, again, similar trend. Not exactly the same, but similar trends. With the water, it looks like there's no rhyme or reason. There's no real trend similarities at all. So again, we assumed that because there was no interfering agent, using just water significantly affected the overall final product, the texture of the entire of the candy, making it so there is really no consistency between the higher temperature and the lower temperature. So our discussion, we use the 4 critical questions that were presented to us. The first critical question asked, what happens as candy's final temperature increases? So as the final temperature is increasing, there's a higher evaporation rate. So with more evaporation, we have a higher loss of water, which is going to have the sugar staying behind, yielding a higher concentration of sugar, thus yielding a firmer texture. The second question, which ingredients influence candy's firmness? So there were a few different factors that you could say influence firmness. Cream, butter, sugar, corn syrup, cream of tartar, they're all going to affect firmness, but in different ways. The cream, the butter, and the cream of tartar are going to prevent crystals from forming, which is going to give the fudge a smoother texture. Cream and butter are both fats, and these fats are going to they're going to interfere with the aggregation of sugar crystals, which is going to result in a smoother texture. And then the cream of tartar is an acid, and acids are used to prevent inversion, which is I'm sorry, not prevent, promote. It's going to promote inversion, and what happens there is hydrolysis. And if you take that word hydrolysis, hydro meaning water, to lyse means to break. So we are using water molecules to break the bonds between things. And in this case, the things are the monosaccharides present in the sucrose molecule. So the sucrose is getting split apart. And that is inversion, and acids help promote that. And cream of tartar being an acid will promote that. So that is going to prevent the crystals from forming. So then sugar and corn syrup, they are not going to prevent firmness. They are the actual substances that are crystallizing themselves. So having sugar present is going to affect crystallization, since that is the solute that is present in this supersaturated solution that is ultimately forming crystals.
And the other question reads, what role does butter play in fudge? And basically, butter acts as an interfering agent. Like James mentioned, butter is a fat, and this actually prevents large crystals from forming. So this ensures a smoother texture of the fudge. And then the other one is, does beating temperature impacts smoothness? And the answer is yes. It does impact smoothness. Beating at the softball stage, which is between 234 and 240 degrees Fahrenheit, actually produce a smoother texture, while higher temperatures yield a firmer and possibly a grainier texture. So if you want a softer fudge, you definitely would need to start beating it at the softball stage. So as you can see, these points are actually essential for understanding how cooking techniques and how the ingredient choices affect the final quality of the product.
So a few limitations of the study. We had pictures of the fudge under the microscope at high temperatures. We did not have them at low temperatures. So not having those low temperature pictures, it did make it a little difficult to assess what the penetrometer depths were telling us because we couldn't tell if specifically if that water recipe was actually cooked all the way through and just like super, super smooth, or if it was just not cooked all the way. The second limitation was that the acceptability data, all of those characteristics, appearance, color, flavor, firmness, and texture, they were subjective, dependent on subjects, but they were also not very detailed. In the previous experiment we did, we saw the subjects actually consume cookies and they were able to say, like, yummy. So we were able to get that part of the response, but we didn't get that here. So it was hard to differentiate between um, creamy, buttery, buttery sweet, creamy sweet. It was kind of hard to tell how to differentiate between those. And then assigning a quantitative number to that was based on, again, our subjectivity. And then the final limitation was that the low fat and the alternative sweetener variations were not carried out. And that had really no effect on our ability to compare what was given to us. It just represents an incomplete following out of the protocol. But again, that didn't really affect our ability to compare anything.
And so for our conclusion, our experiment actually demonstrated that ingredients like cream, butter, corn syrup, and cream of tartar actually play key roles in the candy texture by controlling crystallization and controlling the final firmness and the final smoothness of the product. Also, at lower temperatures, they produce softer, smoother textures, especially when using interfering agents like butter. And um, finally, this knowledge is actually pretty valuable for anyone who is looking to perfect their candy making techniques. Um, so as you can see, using butter and using higher temperatures will actually produce a smoother texture of the final product, and this can actually turn out in a better quality of the product, since we actually want a fudge that is pretty smooth and it's firm but not like super firm, right? So thank you so much for listening to us. Have a great day.
Bye.